This video is all about FDT Porter value and borehole test in road and building construction. FDT. FDT stands for Falling Weight Deflectometer. It is a non-destructive testing method used to evaluate the structural integrity and load-bearing capacity of road and building foundations. The test involves dropping a weight, typically a steel ball, onto the surface of the road or building foundation and measuring the deflection, or flexing, of the surface. For example, if a road is being built on top of a soil foundation, an FDT test would be used to determine the strength and stability of the soil before the road is built. The test would involve dropping a weight onto the soil and measuring the amount of deflection. If the deflection is too great, it may indicate that the soil is not strong enough to support the road, and additional measures, such as soil stabilization or a deeper foundation, may be needed. The solution of FDT is to measure and estimate the structural integrity of the foundation, which helps to identify the potential issues before constructing a building or road, and also it helps to plan and design the foundation accordingly. Porter value. In road design, the Porter value refers to a coefficient that is used to determine the structural capacity of a pavement. The Porter value is used to calculate the structural number of a pavement, which is an indicator of the pavement's ability to carry load. The structural number is used in the design of new pavements and the rehabilitation of existing pavements. The Porter value is determined by measuring the deflection of a pavement under a known load. The deflection is measured using a falling weight deflectometer, FWD, test, which involves dropping a weight onto the pavement and measuring the amount of deflection. The Porter value is then calculated using the following formula. Porter value equals measured deflection, expected deflection, x 100. The expected deflection is calculated using the structural properties of the pavement and the load applied. A Porter value of 100 indicates that the pavement is performing as expected, while values less than 100 indicate that the pavement is overperforming, and values greater than 100 indicate that the pavement is underperforming. In general, a higher Porter value indicates a stronger pavement, and a lower value indicates a weaker pavement. Engineers use the Porter value to determine the structural capacity of a pavement and to plan for rehabilitation or reconstruction of the pavement if necessary. Lab tests are necessary in road and building construction for several reasons. Quality control. Lab tests are used to ensure that materials used in construction, such as concrete, asphalt, and soil, meet the required specifications and standards. This helps to ensure the overall quality and durability of the finished structure. Safety. Lab tests are used to ensure that the materials used in construction are safe for the workers handling them, and for the public that will be using the finished structure. For example, tests are conducted to ensure that soil is not contaminated with hazardous materials such as lead or asbestos. Compliance. Lab tests are used to ensure that construction materials and finished structures comply with relevant codes, regulations, and laws. For example, tests are conducted to ensure that concrete and asphalt meet the minimum compressive strength requirements. Design optimization. Lab tests are used to gather data on the properties of materials and structural elements, which helps engineers to optimize the design of the building or road. For example, soil testing can be used to determine the bearing capacity of the soil and inform the design of the foundation of the building. Cost savings. Lab testing can help identify issues early in the construction process, which can save money and time by allowing for adjustments to be made before the problem becomes too severe. Overall, lab tests play a crucial role in ensuring the safety, quality, and compliance of road and building construction projects. A borehole test. A borehole test, also known as a borehole drilling test or bore test, is a method of evaluating the subsurface characteristics of soil and rock by drilling a hole into the earth and measuring various properties of the materials encountered. These tests are often used in construction and engineering projects, such as building foundations, to determine the suitability of the subsurface materials for the intended use. The borehole test typically involves drilling a hole to a specific depth, and then measuring properties such as soil or rock type, density, porosity, and permeability. Once the borehole test is complete, the collected data is analyzed to determine the suitability of the subsurface materials for the intended use. If you like this information, kindly subscribe our channel and get notification for upcoming informative videos. Thank you.